have a chapter 10 test on Friday, so I'm going to go over some things that we kind of missed on the last test, or the first attempt at the test. And a lot of it was just not fully factoring things, or even just like misfactoring. So the thing that we want to do is we want to, if you are able to factor things out or find common denominators in numbers, you should do pretty well on factoring. We just have to do it completely. So to begin with, we're just going to look at numbers. So we studied that every number can be broken down into a product of prime numbers. And a prime number is any number that is divisible by 1 and itself. And those are the only two numbers that it's divisible by. So 36 is composite, right? Because it's not a prime number. It's we can divide it by 1 and by itself, but we can also divide it by 3, we can divide it by 6, we can divide it by 12. So what we're going to do here is we're going to take 36 and we are going to make it into a product of prime numbers. So the first thing I'm going to do is I'm going to pull out a 2, right? Because this is an even number. It ends with a 6, which means it's even, which means that I can divide it by 2. So 36 divided by 2 is 18. So I take the 18 and pull down here. 18 ends with a an even number, which means it's even, which means that I can pull out another 2. Pull out a 2 and I'm left with 9. 9 is not an even number. So I cannot divide it by 2. But what I do know is I can divide 9 by 3, and I'm left with 3. And we know that 3 is a prime number. So taking all these numbers here and making them into a product is how I will factor this. So 2 times 2 times 3 times 3 equals 36. There are very many different ways we can think about this. We can think about this as 6 times 6, right? 2 times 3, 2 times 3. We can think of it as 4 times 9. We can think of it as 12 times 3. Anyways, there's several different ways to write this as a product. But this is the way we write it, as a product of prime numbers. So I'm going to be doing the same thing with polynomials, or trinomials in particular. So I'm going to take one of the problems that we had on the test. Let's look at x times y squared. So this one's a little more tricky, but the same type of idea applies. So instead of dealing with 36, I'm dealing with a trinomial. But this can be written as a product of primes, so I'm going to do generally the same thing that I did last time. And that is looking at each of these and trying to figure out what do they all have in common. And if you look, you see that this has an x, this has an x, and this has an x. So that means they all can be divided by x, right? So I'm going to pull out the x from each of these, plus 2y plus 1, right? So this is kind of hard to factor into binomials, but this right here we have seen before, right? So one thing you can do is you can take this and you can set it up in a box, like we've been doing. So I know this is y squared up here. And the way we get y squared is multiplying y and y. See that this is a 1 down here. The way we get 1 is by multiplying 1 and 1, or negative 1 and negative 1. So now let's fill in this box here, right? 1 times y equals y, and 1 times y equals y. And if you add these two together, you get 2y. So y squared plus 2y plus 1, right? We got that by multiplying y plus 1 times y plus 1, right here. Y plus 1, y plus 1. And obviously this is multiplying the same thing twice, so I can write it as y plus 1 squared. So the first thing you want to do, step 1, is find a common, we'll just say multiple, right? You could say divider is the same type of thing, but all of these are multiplied by x, right? And so that's why I was able to pull out this x. Step 2, see if they share any other multiples. So we didn't really do this step, but look, the only thing that these three share is 1, right? I can pull 1 out of each of these. I can't pull, the only other thing this has is a y, but I can't pull y out of here, correct? So I can't simplify this down anymore. So the next step, step 3, see if I can write this as a product of binomials. Remember, binomials are just two monomials in an expression. So 1, 2, therefore this is a binomial. So those are the 3 steps that I use to go about factoring things. Sorry that I didn't share it earlier. But remember, it's the same type of idea that we use here, right? You're pulling out different products, right? I should write this. The answer to this is x times y plus 1 squared. But this is the same thing as this up here, right? I guess it's more like 2 squared times 3 squared. It's the same idea, right? We're just using variables here, and up here we're using physical numbers, in this case prime numbers. Yeah. So if you have questions on how to do other factorization type problems, just let me know and we can talk about it Wednesday or Thursday or even Friday before the test. So just let me know.